Hello and welcome to another exciting Breakfast with Unity, your breakfast with of champions. Sorry about yesterday. I had a frog in my throat. My throat's still not perfect right now, but it will deal. So first off, I want to say something about the ragdoll episode. One of our users, I didn't look up the username again. Brought up two of our users brought up information about this. So one of them said what the problem was, and I should have known this one. What had happened here when we were trying to detach the children, we set the child parent to null in a for each loop. But the problem is when we do this causes Unity to implicitly remove this child from the list that we're traversing here, which means that this becomes one-off. So basically half of them weren't being destroyed, and that's what we saw when we actually used this. So if we put this on our ragdoll here and hit play, when the what is this doing? Okay. When the characters delete themselves, half of their body parts are going away. And another user pointed out that there's a built-in function to do this that I didn't even realize existed. If you just do transform.detach children, you're done. So now we don't even need to have this delay in the destroy here. If we just hit save and play, we won't have the problem of the individual parents staying around. It'll just be the bodies, and they will work exactly as you want. Obviously, the hierarchy still is messy in this case. Some people mention that it doesn't really matter as long as you never change any of the transform information on the ragdoll, which that's true. So it's up to your prerogative whether you want to destroy the parent and detach the children, or just leave it there to be in the scene. But just make sure you never move it around, or things might get confused. So that's all we're going to say there. I'm going to go ahead and save this with that change in there, and we're going to move on to our spot shadow. So I'm going to create a new scene. We're going to save it, put it in the spot shadow. And what we're going to be doing is making a just downward shadow thingy for our characters in a game. So we're going to need two objects to show this off. We're going to do a sphere and a plane, and we're going to start with the most simple case and then handle a few extra cases as things go. So let's first create a directional light in the scene. Let's create a sphere because it'll look the best with the spot shadow. And let's create a plane. And the plane we will put at 0. If we go to the game right now, we have a test case here. I'm going to go ahead and bring the camera in a bit. Let's do 5. Sure, that'll work. So it's pretty hard to tell where that sphere is in the scene because there's no shadowing information. So this is actually a really great case. We're going to be able to see a lot better the depth of this sphere after we add a drop shadow. So what we're going to do is we're going to create a script for this, C# script. And we're going to call this. I interchanged spot shadow and drop shadow. I'm going to continue calling it spot shadow because drop shadow can sometimes mean more than what we're doing here, and I don't want to give people the wrong impression. We're not going to be creating a silhouette shadow in any way. This is just going to be a simple spot that goes down. And I try to avoid using the word projects down. I keep wanting to say projects down, but technically we're not quote unquote projecting. Projecting usually implies that we change the scale of things a little bit as they go out, and there are projectors built into Unity, but projection is actually quite slow. So you could use this as a projection style. We may show a projection style later. Not on this episode. So spot shadow, we're going to have a couple of variables. Public float max size equals, let's do 1.0f. Public float, what should we call the rate that it decays? Let's call it max distance. Distance equals, let's make this 10.0f. And so what we're going to do is we're going to just, oh yeah, we're also going to need the drop shadow game object. So public game object drop spot shadow. And all we're going to do is on update, we're going to raycast down. We're going to assume, so normally I say raycast along the Z, like normally we face things around. This is a case where we're almost certainly going to be raycasting down. And when I say down, we're actually going to be doing world down. We could do character down, but it causes problems if you rotate the character and stuff. So world down kind of makes a purpose. Obviously, if you're making a game that's on its side or something, like if you're making a Zelda clone and you decided to make it in 2D mode, and then you're also doing it from the side when you build it in Unity, you would want to project forward in that case. But we're going to hardwire this because most cases it's going to be down. So we're going to do a raycast down if physics.raycast, and we're going to go transform.position as our uppercase, transform.position, transform.position for the initial location. Let me look at our prototype here. We need raycast info. We might as well use the distance while we're there. So origin, direction. So origin is where we're at. Direction is vector 3 dot down. Layer mask. We don't need layer mask actually. So direction, origin, direction, distance. We might add a layer mask, but it doesn't matter. Hit info. So I'm just going to do out hit, and then we're going to define that in a second. And then the last thing is distance. So the distance is max distance. So this will send a ray down and get information from it. We're going to create a raycast hit. We've done this quite a few times, but raycasts are super important. You're going to use them a lot in game development. So we raycast down, we get the information on what we hit. So what we're going to do is we're going to spawn our spot shadow where we hit about. Oh yeah, we should have one more variable here. Public float offset equals, let's do 0.05f as the default. I think that will probably be enough for it to be seen, hopefully. So this is the amount that it'll be off of the surface. So what we're going to do is we're going to spawn our object where it hits. So instantiate our spot shadow. Oh yeah, we're going to need to do something else too, but let's just do this for right now. Game object instantiate. Game object instance equals instantiate spot shadow. The position will be hit.point. The rotation will be, which is the third option here. What we're going to do is we're going to use the surface normal for that. So hit.normal. So hit.normal will give us. We might want to make this negative. I'm going to just leave this as is. It might just work out with however we set up the drop shadow. We might need to reverse it though. So we instantiate it there. And let's just start with that. Let's just do this and see what we get. So if we got a problem here. Hit.normal. Oh yeah, hit.normal is a vector. We need to turn this into a quaternion. Quaternion.look rotation hit.normal. There we go. So this means give me a quaternion that is what would happen if you looked along this normal. Now, so hopefully this will all work. I thought of a couple little. Oh, there's another problem here. Oh yeah, we didn't have our cast in the. So we need to make sure that there's as game object because this just returns object, but the actual object's type is based on the type that you pass in. So this would be a game object. So if you pass in a transform, you get transform back. It's just kind of how you have to work it. So we typically pass in game objects though. So I'm going to add this to our sphere, and we're going to need to create a drop shadow real quick. So we're going to create a. I'm just going to create a quad, and this quad. How does the quad face? That's what I thought. So the quads naturally face opposite of the way I would have set the quads up if I had made them. I would have made them facing the other way. So this is the reason that we're going to have to make this a negative. You could put the negative here or here. I'm going to go with reversing the vector. So, so now we need this to actually look like a shadow. So what we can do is we can create a little material for that. We're going to create a material called drop shadow. And we're going to use transparent, diffuse, and we're going to use the default particle, which is built into Unity default particle. And then we're going to make it black. We're going to tint it so that it is black. And so now, if we put this on our quad, we have a little shadow blip. So so let's put this on our. So we've already put this on the sphere. So let's see what happens here. Let's first call this the spot shadow. And I called it drop shadow here naturally. Spot shadow. Spot shadow. So now we have a lot of objects called spot shadow. Great. So we're going to go into our sphere. We added the thing. We're just going to put the spot shadow on it. And when we hit play, we're going to see that it has a shadow. Of course, the shadow's getting darker, and that's because we're actually painting it every frame. So this is not optimal to what we want to do here. So what we're going to need to do is we're going to need to store this instance somewhere. So an appropriate place is a private instance variable. So private game object spot shadow instance. And this represents the prefab that we're going to be instantiating. This represents what we've already instantiated. And we did this before on our laser. It's actually a very similar concept to what we're doing here. So, whoops, we actually do want. Okay, we don't want this. So what we want to do is we want to change instance to be called spot shadow instance. And we need to do this only if spot shadow instance does not equal null, then we do this part. Otherwise, this will be skipped all subsequent times, and we will just use the spot shadow instance stuff. So also, since this is we're putting positioning information here, but it's going to be different later times. I'm going to actually reduce this to just the normal instantiate call, though I'm going to grab these components real quick. So we're just going to instantiate. We don't care where, but then we're going to actually move the position. So transform.position equals hit.point. Sorry, not transform.position. Spot shadow instance.position. And then we need to do the rotation, and so spot shadow instance dot rotation equals quaternion dot look rotation hit dot normal. So now if we hit save and play, we should get a single. Well, got a problem. Dot transform dot position, because this is a game object. We need to get its transform. So save, play. Oh, we got a problem. What happened? Spot shadow instance. Okay, sorry. If it equals null, not equals. That was silly. So now it should give us one spot shadow, and it should follow around the sphere as we move it. So you can see that we've got some clipping in there. That's because we didn't actually put our offset in. So let's put our offset in right now. So the hit.point should also be added. We should add vector, actually no, plus hit.normal. And we multiply this by our offset. So now if we hit play, we should see that, okay, it's working, but it looks like we have this warp effect. That's actually kind of really hilarious. So what's happening is the raycast is actually hitting our spot shadow. Our spot shadow should not have a mesh collider. Remove component. We hit play. Remove component and apply, because this is the one that's in our scene. And I'm going to go ahead and just delete the one that's in our scene now. So there we go. We have a spot shadow. It stays in the right place. It looks right when we look at it. And whoops, that's not the sphere. And when we move the sphere, it moves with the sphere. That's sweet. So the other thing is we want it to kind of react when we move the sphere up, right? So first of all, our drop shadow, just because of the way that the default particle is, we need to make it a little bit bigger. So we have this max size. We didn't actually use it anywhere. So let's multiply this in. So we're going to make the spot shadow instance dot size, no, dot transform dot local scale equals, we're going to set the scale to vector 3.1 times our max size. So we're going to do that just for now, and hit save and hit play. And now if we go to our sphere, if we go to our spot shadow, or rather we go to our sphere and we change the size here, we can get the size to look different. So let's make the size about there. So 1.5, let's do 1.5. So now we have a shadow, it looks like the right size, but it doesn't change when we change the distance from the ground. So let's fix that. So let's put this back to 1.5, because remember, things don't save in the editor. And let's make it so that it changes size. So instead of it being that size, we're going to do vector, actually let's do float size, current size equals, and we're going to do mathf.lerp, which is a linear interpolation, and it's going to be between 0.0f, actually let's do between 1.0f, so it starts at 1.0f, it goes to 0.0f, and t will be the, what it will be is, so we want percentage of max distance. So if we do our hit.distance divided by max distance, I don't know why it's not in there. This should give us what we want. So if, current size, and actually it shouldn't be 1.0f, it should be max size. And then we take our current size and replace that max size component there. So now if we hit play, we get a drop shadow, and the drop shadow should linearly become smaller as you move it up. And we could make it more dramatic if we wanted to. So if we wanted the sphere to have a max distance of, like, say, 3 units and hit play, we'll have this effect where when we bring it down close, it looks like it's right there, and we bring it farther away, the shadow goes away completely. Well, it doesn't go away completely, so it just sizes down, and then if we are above the max distance, we don't do anything. So we do want to do one last thing. So else, we want to deactivate the drop shadow. So spot shadow instance dot enabled dot active set active false. So if we're too far away, we don't care about our spot shadow, and we want to make sure that we turn it on true if we do care about our spot shadow. And we shouldn't do this before we check for spot shadow instance here. And we should also do this in here. So, actually I've got to do a better idea. Let's do this outside of here, because it doesn't matter. So now we only have it in one place, and it should work. Save, play. Now if we go all the way out, even if we do it really fast, we won't have a residual shadow dot. It will actually go away appropriately. And then we bring the sphere back, hopefully. Yep, we get our spot shadow back. Cool. And what's nice is, since we're using the normal information, that means that if we have our plane, like if we rotate it, you'll see that it actually follows the plane. So that's awesome. So we already had that figured out. Now, obviously, this doesn't support like really complex geometry underneath you. You need to have really flat stuff. So if you have kind of a flatty game, this will work. If you don't have a flat game, you're going to have to do some projection stuff. We'll cover that on another episode. Was there anything else I wanted to cover here? This has overlap issues. Like if you go to the edge here, it will obviously still overlap beyond the edge. I think it's pretty minor. For the type of games that this will be useful for, I think you'll get a lot of utility out of this. As one final thing, let's go ahead and save this scene, save the project. I want to play around real quick and go to the ragdoll initial scene and duplicate it. We're just going to duplicate this scene. It's been 20 minutes. I was going to try adding drop shadows to each component in the because when you have a multi-component thing and you add spot shadows, it actually looks pretty good as long as you don't make them collide with themselves. I'll leave that as an exercise for the viewers. So thank you very much for watching. Hopefully you had a good time. I know I did. And if you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And thanks for watching. I really appreciate it. And you guys have a great one. Donate to the show, patreon.com/cookingwithunity. Gives you access to the Cooking with Unity Super Repo, and also supports our show, which we really appreciate. Thank you very much. You have a good morning, and I'll catch you guys tonight with some Fight Go Right on 2D Thursday. Thank you very much.